Here in this video, I'm working out some homework problems a student had asked. This is number 8 for integration by parts homework. So the problem is integral of 4x cosine of negative 8x dx. I'm going to make my life easy. I'm going to pull the 4 out. And I also know that cosine is an even function, so a negative inside cosine doesn't have to be there. So I'm going to change it to cosine of 8x dx. I'm going to start by, now I can do integration by parts. So let u dv. So use the liat to help you decide what's going to be your u. U is the one that comes first in the liat. It looks like algebraic function, so u would be x and dv would be cosine of 8x dx. For the u, we're going to differentiate both sides. Du is equal to dx. For v, we are going to integrate, and v would be integral of cosine x, sine of 8x divided by 8. And now I'm going to perform the integration by parts. U dv integral is equal to uv minus v du. U times v, u is x and v is sine 8x over 8 minus integral of v du. V is sine 8x over 8 dx. All right, so I had pulled out a 4 in the beginning, so that 4 is still in the front. So I will multiply everything with the 4. I'm going to clean up inside first and perform the integration, then take care of the 4 there. X sine 8x over 8 minus integral of sine x is negative cosine x, so it's going to make it a positive. And I already have 1/8 in the front. I'm going to be dividing with 8 one more time. Cosine 8x plus a c. All right, now I'm going to take care of the 4. So when I distribute the 4 inside, this would turn into x over 2 sine 8x plus 1 over 16, because 4 and 8, we can divide both of them with the 4, cosine of 8x plus c. And that should be our solution. If you had the sine function, you could pull out the sine all the way in the front, because sine is an odd function. You can pull the negative out. In a cosine of theta is same thing as cosine of negative theta, so we can remove the negative inside the cosine. The negative can disappear. This should be the solution here, and we are back to x's. All right, is number 9. Natural log of 9s minus 4 ds. Our variable here is not, variable is different. It's not x like normally it is. So I'm going to go ahead and make some changes. I'm going to do a u substitution, but I'm not going to call it u. I'm going to call it an x, because eventually I would be doing integration by parts and I would be using u dv and u over there again. So I'm going to let 9s minus 4 be x. 9 ds would be equal to dx. ds would be 1 over 9 dx. Now I'm going to write this integral in terms of x. So ds is 1 over 9 dx, and natural log of x. And we have talked about this integral before. So for natural log of x, we're going to write 1 times natural log of x dx. And my u function, u is going to be, think about liat, the function that comes first, logarithmic function comes first, so that's going to be my u function, and dv would be 1 dx. Okay, now I'm going to differentiate. Du would be 1 over x dx, and v would be equal to x. So ready to perform u dv integral is equal to uv minus v du. So u times v, u is a natural log of x, v is x, so x natural log of x minus integral of v. What is the v function? The v is x times du. Du is 1 over x dx. And that leaves me with x natural log of x minus 1 dx, which is x natural log of x minus x plus a c. Now I'm going to go ahead and replace x by whatever we called it in the beginning. X was 9s minus 4. So 9s minus 4 natural log of 9s minus 4 minus 9s minus 4 plus a c. Now we can leave it at this point, or if you want, we can distribute here. This will leave me with, oh, there was also, don't forget, we had pulled something out in the beginning. We pulled a 1/9 out. So what's going to happen to the 1/9? I do have that 1/9 in the front. We don't need to bother to multiply the constant with 1/9 because that, I'm going to multiply with 1/9 in a minute. So this leaves me with 9s times 9s times natural log of 9s minus 4. Okay, and then minus 4 times natural log of 9s minus 4 minus 9s plus 4 plus a c. Okay, now we can distribute the 9 inside, and I don't have space, so I'm going to write my final answer here, maybe in a different color. When I distribute the 9 inside, it turns out to be s natural log of 9s minus 4 minus 4 over 9 natural log of 9s minus 4 minus s, and then plus 4/9 plus c. Now if you want, you can write this as one constant, or you can just leave it like that. Because 4/9 is also a constant, we can combine and just write it as a c, because the constant doesn't really change if you add something. It still remains a constant. And there was one more problem, cos inverse 5 of x dx. So here I'm going to let 5x as t. I'm not going to let it as u, because eventually when I do integration by parts, I will be using u dv v du. So I'm going to let 5x as t. 5 dx will be dt, and dx will be equal to 1 over 5 dt. So now we are going to write it as cos inverse of t, and 1/5 is pulled out dt. Now if I don't have another function, I'm going to just write times 1, and then I get to decide which one of these will be my u. Liat tells me that inverse trig function comes before the algebraic function, so inverse trig function u would be my cos inverse t, and dv would be 1 dt. Now it is time to do the derivative. Du dt would be equal to 1 over, it's going to be negative over here, or du would be negative 1 over square root of 1 minus x squared dx. And if I go ahead and perform the integration here, then v is going to equal t. All right, so now u dv is equal to uv minus v du. U was cos inverse t, and v is t. So t cos inverse t minus integral of v du. V is t, and du is, I'm going to pull the negative out and make it positive in the front, 1 over square root of 1 minus x squared d. Apologize, my bad here. This was cos inverse t, not x, so this has to be t squared dt. So that is going to change. Okay, please change that. This is going to be 1 minus t squared, because we had cos inverse t, we had a function of t, not x. T squared and 1 minus t squared dt. All right, now I'm going to do the, let's go ahead and, all right, so t cosine inverse t plus, I still have the 1/5 in the front, so I'm going to keep that 1/5 all the way out and take care of 1/5 a little later. But right now, I'm going to change this integral. So this is t over 1 minus t squared dt. See, what does that turn out to be? T over 1 minus t squared. We can go ahead and do the u substitution here. We can 1 minus t squared. If I let 1 minus t squared as u, then the derivative is sitting on the top. And let me not call it u, let's call it some other letter, because we already have used the u, and the problem had x's in the beginning. Okay, so let's see. So we still have 1/5 outside. T cosine inverse t plus the derivative of bottom is sitting on the top, so I'm going to let 1 minus t squared as k, just because. And negative 2t dt would be dk. Negative 2t dt will be dk. And t dt would be negative 1/2 dk. So this turns out to be, I can pull out the negative 1/2 dk over square root of k. And integral for t cosine inverse t minus, let me just take care of the negative 1/2 dk. That would be square root of k, which is k to the power negative 1/2 dk. When we do the integration, we add 1 to the exponent. Negative 1/2 plus 1 is positive 1/2, and we divide with the new exponent, which is going to be dividing with 1/2, which turns out to be 2 over 1. So it turns out to be k to the power half, and k was, so 1 minus t squared, 1/2. 1/2 we already took care of. 1 minus t squared, 1 minus t squared square root plus a c. Now it is time to go back and replace t by whatever t was in the beginning. T was 5x, right? So 5x, cosine inverse 5x minus square root of 1 minus 25x squared. Square root of 1 minus 25x squared. And I did have the plus a c, and everything was divided with a 1/5. 1/5 was still in the front, so it turns out to be the final answer, x cosine inverse 5x minus 1/5 square root of 1 minus 25x squared plus a c. That looks correct, so we would have x cos inverse 5x minus 1/5 square root of 1 minus 25x squared plus c. Okay, so we had to use a lot of different variables here, but that should be the final solution.